Hello everyone, welcome to our virtual class for today, and we will talk about memory and how it is involved in a learning of a motor skill. So this is our roadmap for today. Our learning objectives include an overview about memory, and then we will discuss the information processing model in terms of sensory, working memory, and long term memory in a bit of a detail for a few minutes. And then we'll take an example that how this model is applied to a particular skill. And then very briefly, I'll just talk about the cerebellar circuit mechanism, which might operate if we are dealing with a certain skill. And then we'll summarize some of the key points at the end. So if we see the overview of our memory, we should distinct have a distinction between learning and memory. If we are acquiring knowledge, that is learning. But if we are the process with which this knowledge is acquired, encoded, stored, and then can be retrieved back, that's memory. And this is a pretty simple circuit which will I'll say discuss in a bit of a detail in our next slide. We have an input which goes to the sensory memory, it goes to the short-term memory from where it is encoded to the long-term memory, which can be retrieved in case it is needed. So if we look at this information process model, they compare it with a computer. The analogy used here is a computer where you have an input which goes to the central processing unit from where it goes to the memory from where it can always be retrieved. And we have a variety of stimuli in our environment. Some of them are visual, some of them are sensory, some of them have both sensory and visual information. So in case we will see something or we listen to something, it goes to our sensory memory. And depending upon if it's a visual one, it will go to the iconic part of the sensory memory. If it's an audio one, it will go to the echoic part. And if we pay attention, it will go to our working memory. And our working memory's capacity is very limited, somewhere 7 plus minus 2 spaces. And then it has two components. Depending upon the visual cues, it will go and store into the visual spatial sketchpad, or if it's the words or numbers, it will go to the phonological loop. And please remember that we have a lot of stimuli which can have both. So in that case, this episodic buffer will come into play and it helps to store the information via this central executive. And as we have seen in our previous model, this information can either encode into the long-term memory with a few techniques which we'll just see in our later slide. And once it's there in the long-term memory, it can always be retrieved back whenever needed. So let's see what's encoding. Encoding is transfer of memory from the working memory, because it's very short, to the long-term memory. And there are a few techniques to do that. We can have a rate retrieval where we can just speak the words again, and again. Not a good technique for encoding, by the way. Chunking is a good method where we will just collectively have the same words or same stuff together and divide it into chunks so that if we just think about one, we can always remember the other one. And then we have the mnemonics where we can just convert some complex information into simpler one, and those simple things can be remembered and help to recall the complex things. Retrieval, once it's there in the long-term memory, we have a few techniques of retrieving things. One of them is priming. It's a subtle kind of technique. If we think of something, it may help us to remind about the things which are related to that particular stuff. Context is important. In one of the videos, they talk about the learning in a class. So if we learn something in a particular setting, then those things will be easy to retrieve if we will sit in the similar setting. State is again an important thing about retrieval. For example, if we are sad and if we remember something, a sad incident, then all the incidents which are related to that sad mood can be remembered by the memory one after another. It's a kind of a positive feedback which is really bad in cases of depression. Now let's move on to long-term memory. It's of two types: explicit, which is easy to describe, and implicit, which is not easy to describe, and of course it is more practical to do. It can be demonstrated but not described easily. We have a lot of things related, what a lot of types related to these memories, about the facts, which is the semantic, and it's related to episodes, which is episodic. We will primarily concentrate on this procedural one because it helps us to learn a lot of skills, a lot of motor skills in particular, and this part, the skeletal musculature part, because cerebellum is involved, and I just want to talk about it at the end. So these are some of the things which helps us to learn skills which are gross motor or fine motor skills. Now, let's use our long-term memory model to talk about one of the skills, which is golf. I just chose golf swing. So the idea here is that if somebody is a learner, first he learns the skill or reads about it. So that's here in this part. And once he uses the goal swing and start hitting the ball, then depending upon the feedback, which might be visual, if he sees the ball just stopping here or maybe overshoot this point, or depending upon the force by which he swings his um, goal swing. So in that case, it will give him a feedback, and that helps to develop his procedural skills and a kind of the skeletal musculature which he is using will continue giving him feedback unless he becomes expert and learns the skill. And how this is going to happen, we will see in our next cerebellar circuit. So these are two of the things which I feel are important to talk. Now, if we look at this cerebellar circuit mechanism, whenever we start thinking of doing anything using our motor command, then signals from the motor cortex directly go to the muscles. But simultaneously, we have a similar copy, the efference copy, which goes to the cerebellum. And then, depending upon the response of the muscles, an information goes back as a kind of a feedback that this is the actual plan, but this is happening in real. So this feedback information goes to the cerebellum, and then it is conveyed back to the motor cortex to modify the movement, and the movement is again modified at the level of cerebellum and the muscles as well. So once we start learning any movement, for example, a goal swing or riding a bicycle, this, or maybe driving, this whole circuit continues to work while we are learning. However, once we have learned that skill and we becomes perfect in it, then the feedback is always perfect, and it won't need to go to the center cortex, and the whole circuit will just work at the level between the spine, between the cerebellum and the muscles, and that's why we are able to do our work so quickly. Maybe we can say in common words, at the spinal level. So this is a very brief description about the cerebellar circuit mechanism which works. If you look at the key points which we have already talked, we looked about memory and talked about its definition. We also looked at the information processing model. We took an example of golf to try to apply that model. And then at the end, we talked about the cerebellar circuit mechanism to look at to look how this coordination works. Thank you very much. If you have any questions, I'll be more than happy to answer.